Suppose we want to take the sine of the sum of two angles, let's call them alpha and beta. Now it seems like you might be able to distribute the sine inside, but that is definitely not true. The way this works is by taking that sine of the first angle, alpha, and then you take the cosine of the second angle, which is beta. That's the first half of it. Now we have to switch it, cosine of the alpha times sine of the beta. Okay, so again, it's not as simple as just distributing that sine. That is not correct. So it goes sine, cosine, cosine, sine, with that plus in the middle. So then the same thing works if I want to do the difference of those two angles. So it's still going to be the sine, cosine, cosine, sine, but then we're going to change that to a minus. So let's do a couple examples of finding the sine of some angles that are not some of our popular ones, such as the sine of 15 degrees. So what I'm going to do is use one of these formulas by taking two of our more popular angles and getting 15 degrees from them. So since 15 is pretty small, I'm probably going to be subtracting. So let's do maybe 45 minus 30 degrees. I could have also done 60 minus 45. There's many options here. So since I'm doing minus, I'm going to take the sine of the first angle, cosine of the second angle, so sine, cosine, cosine of the first angle, sine, and then whatever operation you did on the inside, you're going to carry that through. So sine, cosine, cosine, sine, keep that sine, minus. Now these are ones that we know. Sine of 45 degrees is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. Cosine of 45 degrees is square root of 2 over 2. And then sine of 30 degrees is 1/2. So putting all this together, we would have a 4 as our common denominator. So square root of 6 minus square root of 2. Okay, let's try another one with radians. So let's say we have the sine of 5 pi over 12. So again, I'm going to rewrite this using some of our more common angles. So thinking about 5 pi over 12, that's going to be somewhere in the first quadrant. So let me grab those first quadrant angles, which were pi over 6, pi over 4, pi over 3. And I'm going to rewrite this with a common denominator of 12. So pi over 6 is 2 pi over 12, pi over 4 is 3 pi over 12, and pi over 3 is 4 pi over 12. So now I can see to get 5 pi over 12, I'm going to add the 2 pi over 12 and 3 pi over 12. In other words, pi over 6 plus pi over 4. Okay, so now expanding this out, sine, cosine, cosine, sine, keep the sine. So sine of that first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. Again, these are ones we know. Sine of pi over 6 is 1/2. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. And sine of pi over 4 is square root of 2 over 2. So multiplying out the denominators, we get a 4 on each of them, so that's our common denominator. So square root of 2 plus square root of 6. Okay, one more. Let's go backwards. Suppose you have the expansion, and you want to go back to what it was. For example, let's say I have the sine of 10 degrees times the cosine of 80 degrees plus cosine of 10 degrees times sine of 80 degrees. Neither one of these are common angles, so we don't know these right off the bat. But what we do know is that the pattern sine, cosine, cosine, sine takes us back to a sine of a sum of two angles. And the two angles are 10 and 80 degrees. So this is the same thing as the sine of 90 degrees. and we know that to be 1.